Yeah, welcome back. In this class, we are going to discuss about the design rules of transistors. Now, as we know that in stick diagram, when polysilicon comes over diffusion or when diffusion comes over polysilicon, a transistor is formed. Now, here you can observe very clearly. Okay, now you can observe here polysilicon comes over diffusion or diffusion comes over polysilicon, then you are having a transistor. Depending upon the diffusion we are using, whether it is an NMOS transistor or whether it is a PMOS transistor. Now don't forget, if the diffusion is a p-type diffusion, then it is a PMOS transistor. If the diffusion is an n-type diffusion, then it is an NMOS transistor. Okay, it is not a depletion mode. Okay, now one more important doubt here is whether it is an enhancement mode transistor or a depletion mode transistor. That is an important point. We know very well in the fabrication process, okay, when compared to enhancement mode and when compared to depletion mode transistor, we are having one extra fabrication step. What is that fabrication step? Ion implantation. Is it clear? That is an extra fabrication step we are having. Now you can observe that for a depletion mode transistor, you should have a ion implantation step, but here in this design rules they are simply calling as implant. Okay, now you can observe this one. You can observe here this one. This is an implant. If there is an implant, then it is a depletion mode transistor. If the diffusion is a p-type, then it is a depletion mode PMOS transistor. If the diffusion is an n-type, then it is a depletion mode NMOS transistor. Is it understood? Now we will get back to the rules here. Now you can observe that we know that what is the minimum width of diffusion? Absolutely, that is 2 lambda. Okay, then what is the minimum width of poly? Absolutely, that is also what? 2 lambda. Now what is the minimum size of your transistor? Means 2 lambda by 2 lambda. I hope that are you clear? That is the minimum size of transistor you can observe here. Is it clear? Now similarly for NMOS or similarly for PMOS, depending upon the diffusion, the minimum size of transistor is what? 2 lambda by 2 lambda. Now this area, this middle area, you can observe this area. Okay, this area you can observe. It is the channel, okay, of your transistor. That means it is a gate terminal and it may be source or drain. It may be source or drain. I hope that are clear. Now you can observe that what is the minimum size of your implant? That is an important question you can observe here. The minimum size of implant is 6 lambda by 6 lambda. That is 6 lambda by 6 lambda. Is it clear? This is about the design rules of a simple transistor, enhancement mode transistor or depletion mode transistor. Now we can talk about, you can observe that we can talk about some other rules which are very important in the design point of view. You can observe this figure very clearly. Okay, you can observe this figure very clearly. Okay, now let's come back to here, important point here. You can observe very clearly this one. Now here if you observe that it is a contact area, you know very well it is a 4 lambda by 4 lambda. Okay, it is what? Contact cut, you know very well, that is what? 2 lambda by 2 lambda. Now very important point here is when there is an implant here, you can observe this implant here. You can observe this implant here. When there is an implant here, now you know very well when poly comes over diffusion or diffusion comes over poly, then it is a transistor. What is the rule? One more rule here is, okay, the implant should be, you can observe this one, the implant, okay, for an NMOS depletion mode transistor. Okay, we know very well we are going to have an implant for an NMOS depletion mode transistor. It should, it should, you can observe, expand 2 lambda minimum. What they are telling that after your transistor, is it clear? The implant should extend minimum. What is the minimum extension should be there? 2 lambda in all direction. Okay, if there is one more transistor here, okay, the minimum, okay, separation between the transistor channel and your implant should be what? 2 lambda. That is the exactly way that what we are telling to what we are telling here. What is the exact rule? You can observe that the minimum separation between the channel of the transistor and your implant should be what? 2 lambda in all direction. That is a very important point. Is it clear? This is the minimum separation, 2 lambda. This is one more rule, and one more rule here which is not pictorially shown here. Okay, now you can observe that you can observe in this side, when you are having a diffusion like this, when you are having a diffusion like this, and when you are having a polysilicon like this, the boundaries of the polysilicon should be minimum what, 2 lambda. Is it clear? The separation, that means here not, we can not talk about the separation here. The boundaries of polysilicon, okay, should be definitely what, 2 lambda. Is it understood? Here you can observe that here they are going to show, let us consider this is your polysilicon, diffusion. The diffusion width should be what, 2 lambda, and if you are having a polysilicon like this, the boundaries of this polysilicon should be what, 2 lambda. I hope that are clear. You can observe how many rules we have seen. That means you can observe that very clearly. The first one is this: when poly comes over diffusion, there is a transistor. What is the minimum size of transistor? 2 lambda by 2 lambda. And how to separate an enhancement mode transistor with depletion mode transistor? Absolutely, with an implant. What is the minimum size of an implant? 6 lambda by 6 lambda. And the minimum spacing between the transistor channel and your implant in all directions should be what, 2 lambda. Is it clear? And you can observe here, okay, the boundaries of polysilicon, okay, should be what, 2 lambda. I hope that are clear. These are the rules of transistors, okay, design rules of transistors in a lambda based design, right? Is it understood? If you are having any queries, please comment. Okay, thank you very much. In the next class we will see the rules of contacts. Okay, thank you very much. Have a nice day.